Thank you for coming out to our session. Hopefully you get something out of it. We're excited to be here. I hope you're enjoying Spring One. So we have 3 presenters. We have 30 minutes. We're actually doing this in a lightning talk format. So we're each going to kind of demo 5 minutes. And if we don't get deep enough or if there's more questions, we have Q&A at the end. And we also have these demos in the Dell EMC booth, so we can ask some of those questions there too. But to give you an overview, kind of the topic that's going to be consistent throughout all of our lightning talks is we're going to be talking about Dell EMC Elastic Cloud Storage, which is on-prem object storage, and why ECS is a really great solution to persistence for cloud-native applications. So when we bring ECS to the party with Pivotal Cloud Foundry as a platform, along with Spring Boot and the Bootstrap capabilities, we have a really great all-in-all solution for cloud-native applications and persistence for those apps. So I'm going to start with some basic concepts around the ECS Service Broker. So I'm going to go over that in kind of 2 examples of how we would build out a Spring application that uses S3 services from ECS before the Service Broker and after. So in a scenario where we have ECS in our organization and we as a developer want to connect to that, without the Service Broker, there's a few things we're going to need to do in advance in order to get access to that system. So first, we need to maybe work with a storage or service or systems admin in order to gain access to that system. We're going to need to pre-provision any resources in ECS, like S3 buckets, namespaces, or whatever that we want our application to utilize. And we're going to need to remember or note down all the different URLs and credentials and connectivity parameters that our application will need to connect to that service. And then we need to bring it into our application in order for it to run. So I actually have an example of this where I've gone into the ECS test drive, which is a hosted ECS instance by Dell EMC. And I've pre-provisioned a bucket here, and I've brought in all these credentials for it into an application YAML in a Spring Boot application. And I was kind of new to ECS. I'm not familiar with all of the terminologies and things like that. So this took me about 45 minutes to an hour in order to pre-provision the resources and bring it in here all formatted in the right way. So that's a significant amount of time, I thought. But we can run this application. I actually have it running locally already. And we can see that it does work, in fact, when I navigate to the application on localhost. And it connects to this S3 bucket. It will upload a file and store it there. But I've uploaded a sad face because I don't think this is the best way to accomplish this task. First of all, it took me a while, 45 minutes to do it. I could have maybe been writing new features into the application. And also, I know that I'm not strictly adhering to the 12-factor principles because I have these credentials and connectivity information packaged within the application itself. So this is where the Service Broker comes into play to kind of make some of those things a little smoother and a little bit better. So we'll see an example of using the Service Broker to create the service and use it in our application. And the time goes down to about a minute when I do it this way. So here, I'm now running on PCF, and I have the Service Broker available to me. So when I run CF Marketplace, I see all these services that are made available in ECS. So there's bucket services for S3 buckets, buckets with file support enabled. We'll see some examples of that later, namespaces, and all of those types of things. So I can really quickly create a bucket service. And what we're going to see in just a few seconds is that the broker has gone out to the ECS system and on my behalf created this service for me in a matter of seconds. And then I have the same Spring Boot application, but the main difference is that application YAML file no longer is part of the application. I've taken it out. And I have in my manifest that I'm going to bind this application to the S3 service, which I just created. So this is going to take a little bit of time, but we'll see that this application is going to be bound to that S3 service. We're going to see, again, this without the application YAML and without those credentials and URLs there, we can still connect to this S3 service, and we'll see that. We'll see that the broker is actually handling the ability to connect to that as well. Just a minute here. All right. So how is the broker helping us here? And how is our application going to be aware of this S3 service without it being part of the application itself? Well, what we see, and if you're familiar with how service brokers work in Cloud Foundry, this won't necessarily be new, but the broker has, when it binds to that application, the broker provides these credentials, the URLs, and everything that's needed in the VCAP services environment variables where that application is running. Also, what the broker has done is generated these credentials when we did the create service. So if we go over to this demo application running in Cloud Foundry, we can upload an application or a photo. We see that it's being stored in the S3 service, and we can be happy with all the time we saved and happy that we're adhering to the 12-factor principles. So that's kind of the service broker basics, and Aaron's going to talk about how to wire in some of those credentials from VCAP services into a Spring Boot application with Spring connectors.
Cool. Thanks, Maggie. So ECS loves Spring Cloud, and to that point, we support a couple different Spring Cloud connectors that we've developed. I'm going to show one that is the ECS Cloud Connectors that uses the AWS S3 SDK, so the one that Amazon maintains. There's another one that uses JClouds that supports S3 and OpenStack Swift and a few others, but I'm going to concentrate on that. So in the app that Maggie showed, she showed you the configuration parameters. Whoops, wrong IntelliJ. That's the right one. So you have your application YAML configuration, and then in order to consume that, you have a few things that you need. So Spring developers are often already familiar with this. You have to create a configuration class that can load those configuration parameters into a POJO, and then I have to consume that by some bean. And so here I'm wiring in the configuration, and then I'm injecting that configuration into this bean, and the bean is my S3 connector class, which is just a simple class that I created to bundle together the S3 SDK client together with your bucket. So this is still the manual example. So if you're doing this configuration processing manually, you have to know the configuration, bundle the configuration, configure it into your classes, and then know the best practices for setting up your SDK client. And then once I've done that, I can actually use it. And so here I've created, this is the same demo application that Maggie was running, but it uses that S3 SDK to do listings of buckets, deletes, puts of new objects, and then generating URLs from it. So I'm going to switch over to a different branch that uses Spring Cloud, my master branch here. And so in Spring Cloud, I'm accomplishing all of the same things, but this YAML file is there, but it's not used for this. It's getting it from VCAP services. But instead, I just have a single bean that I create, has the same class name, but this is actually coming from the Spring Cloud connector. And I just instantiate an instance of this bean using the Spring Cloud connection factory. And so I just tell it, hey, I'm expecting for there to be S3 services available in this cloud. Spring Cloud, please give them to me. And that's all I have to do. The Spring Cloud Connector is already, the SDK is already configured with the best practices for ECS, and has all the credentials from the SDK. So I'm using the exact same controller that I was using before, but it's leveraging that. So I'm going to take my Cloud Foundry instance, and since Maggie did it through the CLI, I'm just going to do it through the GUI to show you some variety. And I already have my app pushed. I just didn't start it because it didn't have a bucket. So I'm going to create the service and bind it here. And then once that's created and bound, it flips over to my application view. I'll start it. It'll start pretty quickly. Let's take a look at the logs real quick. Let me ignore that. I bet we're started by now. There we go. And I'm going to upload this because we need it here for a future demo too. But so that's the Spring Cloud connectors that are part of ECS and you can bundle in with your app. So I'm going to flip it over to Paul, who's going to talk about legacy application support with local volume services.
Thanks, Aaron.
You got it.
Okay, where do I go here? Slide deck is
First one.
first one. This one. This one. No. This one here. Alrighty.
Oh, they're reordering on us.
So so we're going to talk about volume services and combining Dell EMC's ECS with volume services. As Maggie pointed out, Dell EMC ECS, when you use the service broker, you can actually create file buckets. So that's a bucket in ECS that also supports NFS. So you can talk to that thing through the NFS protocol. And we all know what Cloud Foundry is good at. It's good at running 12-factor apps, and we've had a lot of success doing that. But with the lift and shift, there's some apps you can put up there, but there's a bunch of those apps that were written 20 or so years ago that expect to write to the file system. Under the rules of the 12 factors, the file system is ephemeral. So if you write to the file system in Cloud Foundry without doing anything else, and Cloud Foundry decides to shoot your application in the head and start it up in another container, all the files you have written will have disappeared. So you can use volume services, which gives you a reliable, non-ephemeral NFS share mounted into your application container. So let's have a quick look at that. I will go here. So actually, I will go here. So I have a monolithic application pushed to Cloud Foundry, and you can see that it does document management-y type things, right? So I can, if I get my mouse here, I can drag and drop things up here, and hopefully it uploads, and you can see I get a rendition, and so on. So let's have a look at that. If I change tabs here, and I just need to change CHG, change CF environments. And if I do a CF apps, you can see that app is running there, and you can see there's just one instance. So it really is a monolithic web app, a while that I've pushed to Cloud Foundry here. And if I have a look at the environment for that thing, sorry, my typing is appalling, even though I've been doing this 20-odd years. If I have a look at the environment, you can see in the VCAP services, I've got something that looks very similar to what Maggie and Aaron were showing, but it's an NFS volume mount, and you can see there's kind of like this volume mount instruction here where the service broker said to Cloud Foundry, when you spin up this container, mount this volume at this location. And so let's have a look at how that actually manifests in the container. So I'm going to SSH into the container, hopefully. And then if we do a df-h, you can see that there is my volume mount that Cloud Foundry is mounted into my application container, and it's buried under var vcap data somewhere. And then if I actually copy that thing, because we uploaded a file, right? So if I cd into that thing and do an ls, you can see there's some GUID file, which is potentially the content that we uploaded, but let's just double check that. So let's upload another file there, and that worked. We'll go back here and do another ls, and you can see that that is in fact written. So we're actually storing, the app is writing NFS, and it's storing it in an ECS bucket. Now, this app was written 20 odd years ago, let's say, and I'm pretty sure that that app was written not to write files to some weird location under var vcap data, right? So we have to configure the application to write its files to the correct place. And we can do that with another Spring Cloud connector called Spring Cloud Connector for NFS. So if this happens to be a Java application, then you can, in your Java config, which we're all now very familiar with, you can use the Spring Cloud Connection Factory to get an instance of the NFS service connector. And this thing services that information that was in vcap services. It surfaces that in your application as NFS service connector Java object. We can then use that Java object here, get the first volume mount, because I'm cheating a bit here. I know there's only one volume mount. And I can get the directory that was placed in the container, that weird location under var vcap data. And I can feed that into the file system resource loader, which I know in this application is the main service that does all the file management. And doing this, we've configured this application to write to the correct location, which is this reliable, non-ephemeral file system, which is actually a bucket in ECS. Now, the fact that this is a bucket in ECS is kind of interesting because we've got a legacy app writing to a bucket. We could, if we wanted to, now go ahead and rewrite this application and run both side by side. So we can incrementally develop the new application whilst giving the users access to the old application so they have undisturbed access. And we can keep iteratively adding features to that new application. But wait a minute, this thing was built like 20 years ago, right? And this thing got divested years ago. And it's going to be way too much work to rewrite this. Well, possibly not. So where's the slide deck again? Here, yeah. So, so if you use some Spring libraries that we've come up with called Spring Content, and you pair that with Spring Boot and Spring Data, it's actually remarkably easy to write this sort of application, and in fact, any other type of application that has to handle unstructured data. So let's have a quick look at that. So we'll flick back here. Now, I'm going to flick to this new tab. It looks the same as the old one because we're rewriting the application, right? And you can see here that I can upload files, and hopefully this will work because it didn't earlier. Oh, there we go. And we get our rendition, and actually if we enter a search key over here, right, it will do a full text search for us. Perhaps let's upload one more. Oh, and you can see this does the job, and then maybe I'll look for Fox. And you can see it's actually looked inside the document, so it's doing a full text search. So that's pretty cool. So let's have a look at what it took to write that application. So I bootstrapped myself with a Spring Boot app from start.spring.io or from the embedded new wizards. And the first thing I do is I'm going to handle the metadata for our document, right? Because we're going to wrap our content in metadata. So I add a few dependencies. I add Spring Data for JPA. I add the H2 database, but this could be any database. It could be a scale-out database like Apache Cassandra. You just have to change the dependency, and I add Spring Data REST. Having done that, I can then go model the data I want to store. So I create myself a document class. I give it an ID, and I annotate it with that ID, which tells the database that this is the primary key. Don't worry about the content-related metadata just yet. And I give it a couple of representative fields. This is the information I want to store about my document, title and author. Having done that, I can then go and create my Spring Data repository. We're all familiar with these by now. This thing extends CRUD repository, and it's typed document. And this gives me create, read, update, and delete operations on this thing. Now, Spring's opinionated, right? So it's going to look at this interface I've just written. It's going to look at the Spring Data dependencies I added, and it's going to inject an H2-based implementation of this interface for me, meaning that I don't have to write it. So labor saving, this is all good. We also added Spring Data REST, so it's going to inject a REST API for this thing as well, which our single-page Angular UI service is actually going to talk to, right? So again, I didn't have to write that thing. So that's my metadata handled. Now we need to store the actual content. So I go to my POM, I add a couple of more dependencies. So I add Spring Content for S3 because we're really storing this in an Dell EMC's ECS, which is an S3 compliant store, right? And I add Spring Content REST. These should look pretty familiar. Having done that, I can then associate my content with my document class by annotating one of the fields with an @content ID. In this case, I've chosen to reuse the primary key as my content ID too. And then I can also add a couple of extra bits of metadata, and I annotate those with Spring Content Annotations, and it's going to manage those on my behalf. Having done that, I can create the equivalent of a repository in the Spring Content world, which is called a store. And I make a document store that extends a thing called Content Store, and this gives us create, read, update, and delete access on content. It's actually a stream-based API. And now there's a few of these you can choose from, but Content Store is one that's particularly well suited to document management-y type apps. And again, Spring's opinionated, so it's going to look at this code, it's going to look at the Spring Content dependencies, and it's going to inject an S3-based implementation of this interface for me, and it's going to put that REST API on top, which the Angular UI single-page app is going to talk to. And then that's our content handled. So we've done our metadata, and we've wrapped the metadata around some content. But if you remember, when we uploaded documents, we saw a rendition, and we were able to answer full-text queries. So how do we do that? Well, we go back to our POM, and it's really easy. We just add a couple more dependencies. Spring Content Renditions, which is an out-of-the-box set of renderers that know how to take content in one format and turn it into another format. And then I add Spring Content Solar, which is an integration with Apache Solar. And you could also add Spring Content for Elasticsearch, who support that too. Having added those dependencies, I can return to my document store, and I can mark it as renderable, which gives me methods to do renditions, and I can mark it as searchable, which gives me methods to be able to answer full-text queries. And again, Spring is going to inject implementations of those into the store and into the REST API, so my Angular front-end app can handle that. And then all up, that enables us to rewrite our application, right, which is fully functional, and we've written a whole content management app with just one class and two interfaces. And I think you agree that's pretty impressive. And all this is running against Dell EMC's ECS. So I'm now going to hand you back over to Aaron.
Thanks, Paul. So, for my next demo, what I want to show you guys is a feature I've been waiting to develop for a long time. I'm pretty excited about. It's the ability to share content across multiple PCF instances using a shared bucket in a way that's native and compatible with PCF. So we added this support to the broker so that you could say, if I have a green deployment of an application in PCF instance 1 and a did I say green first? Blue in the other. I can have those two app instances that are sharing data. ECS has an interesting characteristic where it's strongly consistent and geo-distributed. So I don't have to wait for eventual consistency replication to catch up. I can operate on this as if it's really a single storage platform. It just happens to be geographically diverse. Object storage can, of course, be accessed over the WAN because it's based on HTTP. So you don't have to have an ECS in every cloud where you want to run a PCF instance. So you could also use this to cross data across multiple public cloud and private cloud options. I could have a PCF instance running in AWS or Azure, and I could have a PCF instance that's running on-prem on top of vSphere. So let's demo that as well. So the first thing that I need to do is make sure that I'm in the right window. I am. All right.
You might be in the wrong.
Yep, that's okay. I know. Yep. All right. You guys didn't see that? All right. So I have my application that I deployed before. I have my service that I deployed before. So now I want to connect this bucket up to a remote Cloud Foundry instance. So I'm going to do that by creating a service key that lets the broker know that remote PCF instance is authorized to create an instance based on that bucket. I'm going to pass a special parameter that lets it know that this is for a remote connection because it's a special type of binding. So now let me take a look at that service key. And I'm going to copy it out once I can find my cursor. Oh, there we go. So now I can connect to the remote Cloud Foundry and I can connect up this bucket. I don't know why that's not doing what I want it to do. There we go. So I have my app pushed, but I've stopped it because it doesn't have a bucket. I don't have any services yet. So now I'm going to create a service. I'm going to call it the same thing, but that's just for convenience sake. Oh, I have to do things in the right order. It's an ECS bucket. It's 5 gigs, and I'm calling it my demo bucket. And then again, I'm going to pass some custom parameters for the remote connection. So now I've got a service instance in that other cloud. And what this gives me the ability to do is if I delete the bucket from one cloud or the other, the broker's aware that there's different instances of that. So I don't have risk of leaving that bucket orphaned, and as I continue to use that service, bind it to additional applications, everything works as you would expect. So I'm over in that second Cloud Foundry instance. I can see that I've got my demo bucket over here now. My application is stopped. Let me bind that service to it and start it. You're going to see the same application. You guys are going to be bored of this image uploading app. But that's okay, we're almost done. Hasn't started yet. It's almost started. Uh-oh, it crashed. Don't fail me now. Why would you have crashed? There we go. And see, I connected to this from the remote Cloud Foundry, and it already has my image that I uploaded earlier. I can add another meme. I can flip back to that other one, and it's strongly consistent. I just didn't add auto refresh. I can delete from one, and I can flip back over to the other. And it's all strongly consistent, spreading this data across these two PCFs and potentially across these two clouds. So I think we are about at time. Are we? Yeah. So we've got more to share. We weren't able to fit them all into 30 minutes. So if you guys are interested in more, feel free to come by the booth. And thanks a lot.